In this question, we know the rigid structure have a circular hoop and a square, and it's rotated at a constant speed about a vertical axis. So we first look at the circular hoop. We all know that if the rotation axis is passed through the hoop centers, we can know the rotational inertia is equal to 1 second times mass times radian square. And then we can see that the axis is parallel to the rotation axis. So we can use the parallel axis theorem. And then we can know the rotational inertia is equal to the centers of the rotational inertia plus mh squared. So we can get the hoop rotational inertia is equal to plus mass radian square is equal to 3 second times mass times radian square. And then we see about the square. The square is made of the 4 thin bars, and we first look at this bar. Its rotational inertia is 0 because it doesn't have radians. And then we look at this bar. We can see this bar as a point with the mass. So we can get the rotational inertia is equal to mass radian square. And then we see these two parts. We know that their rotational inertia is equal to 1/3 times mass times radian square. So we know all parts of the rotational inertia. So we can get the total rotational inertia is equal to I1 plus I2 plus I3 and plus I4. And we get the answer is 19.6 times mass times radian square. So we can get the answer is equal to cos mass 2 kilogram and the radian is 0.5 meter square. So we get the answer is about 1.6, and the unit is the kilogram times meter square. And this is the part A answer. And then we look about the part B. We need to know the angular velocity is equal to angular divided by time. So we can get the answer is 2 pi divided 2.5, and it is about 2.51 radian per second. And the angular momentum is equal to rotational inertia times angular velocity. So we can get the answer 1.6 kilogram times meter square times 2.51, and the unit is radian per second. So we can get the answer is about 4.0, and the unit is kilogram times meter square per seconds. And this is the happy answers.